Alright everyone, welcome back to the day 8 of our daily lead code challenge, and today we have got count, prefix and suffix pairs. So before we even begin the question, I want you to understand what is a prefix and what is a suffix. So prefix is a character for for a word, right? You could say a prefix for a word is that word which is obviously its substring because it's out of that word, but the thing is it should any word that starts it kind of starts with that word, that would be its prefix. It's like before, and suffix is that word ends with that particular suffix. So for example, a prefix for the word, let's say a b c d, would be something among these, either this word or this word or this word or this entire word. So it's like this word here ABCD starts with A, it does start with A. This word ABCD starts with AB, it does start with AB. This word ABCD here starts with ABC. All these statements are true because all these are prefix. It's like a word that is added before the word, so it's like prefix. So this is the definition of prefix, and for suffix is what a word that ends with that word. So example, in this case ABCD, D would be a suffix for this word because it ends with D, and then in the similar condition CD will also be a suffix for this word because this word ABCD ends with the word CD, and then again the word BCD is a suffix for this word ABCD because it ends with B, C and D. So basically a suffix or a prefix are the words by which a particular word for which we are finding it for ends with in the case of suffix and starts with in the case of a prefix. So for example, if I had a word, let's say ZXCY MB, in that case the prefix for our word, let's say if somebody asks is ABC a prefix for this word, it's not, because it doesn't start with an ABC. Is ZXC a prefix for this word? Yes it is, it starts with ZXC. Is ZX a prefix for this word here? Yes it is, because it starts with ZX. Is YMB a suffix for this above word? Yes it is, because it ends with a YMB. Is B a suffix? Yes it is, because it ends with. So we see we are doing a starts with and a ends with. In Python there is a particular function called as the starts with and ends with, which can help you identify if a particular word is a prefix for a word or not. So word X will be a prefix for a word Z if the word Z starts with X. A word Y will be a suffix for the word Z if the word Z ends with Y. So this is the particular function which we are going to use in this question. And now to do this, what the question asks us is, like, you need to find all those pairs of words. Let's say this is one pair in which the condition is, what is the condition? Let's quickly take a look. Is like so basically here it's like we need to find pairs of I and J where the word at the I index is a prefix and a suffix for the word J, the word at index J. So this is the condition that it needs to satisfy, and we need to find the count of such pairs. Now if we take a look at this example here, let me draw this. So we have got array of words as ABA, ABA and AA. So now we need to find all those pairs where I and J pairs, like where I is the index and J is also the index. We need to find such I and J pairs. It could be J could come here as well, I could come here, but the condition is that the ith word, the word at index I, should be a prefix and a suffix for the jth word. In this example, if we take a look, the pair right here, right, this pair right here, A and ABA, this A is both a prefix and suffix for ABA because this word ABA starts with A and ends with A. So this is a one valid pair. Now let's see if this A pairs with any other word. It also pairs with this word right here, because this word, big word A, both starts with and ends with an A. So this is another valid pair. Let's see this word on the last. This is a valid pair because the word A, the word double A, both starts with and ends with an A. So this is a valid pair. Now let's come on to the next index. Let's see if ABA is this a good pairing? Yes, it is, because both ABA starts and ends with ABA. So this is another pair. Now let's see if this is a pair. No. This is a pair. Is this a pair? No. Is this a pair? No. So far and so forth. We found only how many different colors we have? 1, 2, 3 and 4. So that's why the answer for this test case is 4. We have 4 valid pairs. Let's take the other example, the second one. So we have got PA, MA, MA. Now in this case, again the same step we're gonna do. We'll start making pairs. First pair is this. Is the word PA a prefix and a suffix for the word PA? Yes, it is. Yes, it is. It starts with and ends with this word. So we got one pair right here. Is PA and MA a pair? No. Doesn't start with or ends with. Is PA and MA a word pair? No. Doesn't start with or end with. Let's go with the PA word now. Again, doesn't work. Doesn't satisfy. Now let's come to this one. So we see this word MA is both a prefix and suffix for this word right here. So we got a pair. And then again, MA has no words to pair with. You can take a look, like it's not gonna satisfy with any other word. So for this case, it's just gonna be 2 pairs right here. So this is what we're gonna do. Since the test case, like the length of the words here is maximum up till 50. So we can do a brute force and it's not gonna take a lot of time. This brute force method is gonna be actually quite helpful. We're gonna have to pair each word with each word, with just the condition that let's not pair any word with its own, because if that's the case, then it's gonna be true. We cannot pair PA with PA. If we do the brute force, right, we do a for loop for this loop and then again the other loop. So we'll have something like this. We'll have a total number of combination as 4 into 4, 16 combinations. Out of these 16 combinations, we need to neglect combinations like these, each word getting compared to itself. In that case, it will be true always, but we don't want that. It's going to disrupt our answer set. So we'll do a pairing, but we want to ignore pairs where the values are same, and then we'll compare every other pairs after that. And then again, the simple condition we need to check for a prefix or a suffix is starts with and ends with. If it's true, we increase the count variable. So let's quickly code this up. Let's declare a count variable to keep our results, and a quick for loop. 2 for loops we'll need. For r in range len of words. Let's keep this an I. So we'll be getting 2 words, right? Words I and words J. So as I said, we don't want to compare 2 same words, so we'll just quickly do a condition here. If words I is not equal to words J, only then we need to compare, right? And again, this comparison is going to be the comparison that the ith word should be a prefix and suffix for both, for the jth word. So a quick check here would be if words J, for a prefix, this words J should start with the word I. So it had this function right here is what I was talking about, starts with words I, and it should start with for a prefix, and to be a suffix as well, it should also end with that word. So words J dot ends with. If this is the case, the words I, for words I to be a suffix prefix, for words J should start with that, and for this word to be a suffix, it should end with that. it starts with and ends with. If both the conditions are true, let's just increase the counter variable, and in the end we're gonna return the count. So it's gonna pair up, it's gonna do those comparisons, gonna pair other than the same ones, and then do the prefix and suffix check. If it's true, we're gonna return the count, increase the count by 1, and then finally we're gonna return the count. So let's do a dry run here and see if it's running, if it's our test cases are passing. Okay, so the last test case, if you see, alright, this one is not passing, it seems. Why so? Okay, yeah, so again this word, right, it's getting compared with, and I think we missed a condition where I is less than j. So to keep that in mind as well, if words I is less than equal to is not equal to, first thing that we need to make sure is the words are not same, and the other thing that we need to make sure is I is less than j. Just quickly just put this, because it's gonna pair, it's gonna do all the pairings even for I which is greater than the j. So like this is our ith loop, it's gonna run for 0, 1, 2, 3. When it's on the third one and this loop starts at 0, I will be greater. We don't want that. So to skip those test cases, we can just simply say where only cases where I is less than j. Now let's run this. This should pass the last test case as well. Yeah, simple condition to check that. So basically just two conditions I need to follow. First is we don't want to pair a word with its own, because in that case it will be true and we don't want that. So we are excluding those words, and we are also including pairings where we are comparing an ith word with a jth word where the ith index is ahead of the jth index. We don't want that. So we are excluding that as well. Only if this condition is satisfying, we are going to check if the word at the ith index is a prefix and both a suffix. This function right here, starts with and ends with, is what Python provides to quickly check if a word is a prefix in case of starts with, and a suffix in case of starts with, and a prefix in case of ends with. So these two functions help us to identify words which are a prefix and a suffix respectively. Now let's try to submit this code. Okay, this test case is failing. It's BB and BB right here. It seems like the words should be unique, it seems. Alright, let's take a look why we got this answer as wrong. Okay, instead of comparing the words, instead of checking the words are same, let's not do that. Let's just say the index are not same. Basically this, yeah, just this condition will work, because we can have same words on different indexes, right? Let's also do a custom test case. We can have the same word at different index, so that is why it's better to not compare indexes at the same index, or basically just I less than j, because this I less than j is covering the index condition where I is not equal to j as well. So yeah, let's quickly run this custom test case as well and see. Now it's satisfying. Now I think this should run fine. Yeah, so it says it takes 9 milliseconds to solve this, and it implies the complexity, it's going to be n square, but for our test case it's fine because it's just 50 in length. So that was it for today, guys. Like and subscribe. I'll see you guys tomorrow.